taking AI actions just, you know, presses virtual buttons on a controller. And sometimes it's easier to make an AI that uses a virtual controller than it is to make an AI that directly controls what the entity does. So if the movement controller was looking at the virtual controller, then like we could hook up, you know, an AI for the player, and it would be able to, like, you know, hit the X button to dash or hit the B button to dash, and it would work just the same way that a player would. Alright, so if the movement controller looked at the virtual controller, this is easy for player actions. This is difficult for AI actions. Like an AI might, you know, have more actions that it needs to do than a controller would easily map. So it'd be nice to look at flags or something else that we could set, but I don't want to throw up a whole bunch of barriers. The question is, how do we get a dash from our logic controller to our movement controller nicely? Well, let's think about it. If I was writing an AI for Bitey to make him run and jump for platforms, I would basically have him run, and then he needs to do his dash to switch gears when he gets fast enough. So he's going to be looking at the speed, and he's going to be like trigger dash every single time to try to get to the next stage. So it's not even like we don't even care that it's going from like trot to sprint or something. I mean, we might. So like, do trot, do walk, do blah. But if we just said like hit the X button, it'd be okay. I like the idea of using the virtual controller. Then basically we could slap the player on top of anything in the entire game, and you'd be able to play as that thing. Like, it wouldn't matter. You could just use it. Like, if you could play as a Prowly, and maybe the controls are complete crap, but it would work. And it also probably segments everything nicely into actual actions instead of just specific logic that we'd be doing crazy things with. Do we tightly couple the logic to the movement controller? Like, if the movement controller grabbed it and then cast it to a specific thing. So like the Fat Sack AI actually grabs the Fat Sack movement controller and says, yep, this is what we're calling. Then it can actually call all the things that we need. So that would be the other option here, would be the logic controller directly calls the movement controller. In which case, we could do that. We could make that like interface thing that we had before, that we were messing around with earlier today. And I could make like a blueprint interface and be like, okay, well, if you want to be able to, you know, control the player here, then, you know, these are all the player actions that you can call in your movement controller. That wouldn't be the worst thing in the world, actually. Like, we call get movement blueprint and see if it's an instance of a thing. I kind of like that idea of the logic controller directly calls the movement blueprint controller. So inside of here, we'd have like a new area which would be, so it's like add comments, it would be like dash. So we'd like snag the movement. We'd do something like, I guess we could actually have lots of things like this. I mean, we can't specifically componentize it. So let's add a reroute node on each side, and then so if we go over to like our movement control and we make like an interface, a blueprint interface, and we say Bitey movement interface. And let's see if we can actually do anything with this. Like parent class is interface? That's not what I want. I want the parent class of this thing to be something else. Alright, let's call this one dash. And it should take nothing. Let's just have it take nothing and be good to go. Why is this read only? Well, I want to make a function, I guess, but I want it to be based off of a blueprint? Hello, Karakan. I am trying to figure out how to use like a... I want to be able to define an interface for a blueprint and call it. So be like, I want to call onto my movement controller and be like, hey, if you have a dash functionality, I want you to dash. I'm not sure how to do that. Maybe I can make a custom event. Like if I add a new I don't need a graph. Maybe I can just do something like this. Alright, so if we hook it up like a custom event, maybe I can do it that way. Alright, let's see. How do I think it's just like, how do I call custom event on Blueprint? This is not how I'd like it. I basically want to call this thing, but I don't want to have to... Can I call something by name? Like I want to send a message to... I want to send a message to this object and tell it to do something, and I'm not sure how to do that in Unreal, the correct function. Like, am I supposed to use an interface for all these things to be able to use, or am I supposed to set something else up? Like, I want to call on this thing if it exists, and only if it exists. Otherwise, just like, don't worry about it. Yeah, I'm not sure. So if I had an interface, like how would this interface work with this thing? Oh, implemented interfaces. It's right here. We can add the dash inherited interfaces. How come I can't? By movement interface? So let's add a speed float in this thing. Alright, so we want... No. Delete. How do I get... Alright, so we compile this. Alright, found more than one function, second occurrence of none. Alright, so it's found more than one function with the same name as dash. Alright, so let's call this something else, like dash D. If we compile it, it's fine, which is not what we want. We want this to have to exist. Is there some sort of... Maybe I should read this real quick. Alright, so we add the interface, and then interface can be removed. The inherited implementing interface members. When an interface is added to a blueprint, the blueprint must implement the interface's functions in order to have them. This is done by placing event nodes for the interface functions in the event graph. The nodes connected to the event define the functionality or implementation for the function. Alright, so what we want is like this. Okay, that's actually pretty cool. So basically what we want to do is call dash on this thing like this, using the interface for the blueprint. Magic. And let's give it a speed of 123.5. And let's grab the virtual controller up here and basically do a key triggered. And let's do it for the X action. And then let's do a branch. Alright, so what I want to do is I want to have this guy run all the way up here and have this guy run all the way down there. It really doesn't like that. And so if I hit the X key, attempting to dash. Alright, that's pretty cool. And I'm actually going to change this to the B key. Alright, so that's how we're going to call. We're going to call through interfaces and blueprints and all that. And our movement controller should do it. So I am happy with that. That's pretty baller. So, alright. So we'll just set up our basic interfaces, and that's how we'll call across. Is we can grab the virtual controller if we need to, but we can have our logic call through an interface into the actual movement controller, and then this movement controller can like figure out what to do to be like, okay, there's a dash here. Let's grab the current state. All right, so let's make sure that we can actually grab the current state then inside of our controller, so we can actually call something on it. So we want to get current movement state. This should be state. And then we're going to call like get name on it. Yeah. How do we clear it? Just like that? All right. Attempting to dash in state walk. Awesome, so we can just do that sort of stuff then. And we can get our movement state however we please. And if we wanted to call dash or something else on it, we could just have these same things implement, the interface and then call directly on them, or we can just use casts in here, or we can even grab the states. I should actually have a get state by type or something else like that inside of here, so we can like get our state. So let's go ahead and make that. So we're going to make a get state. Can we templatize Blueprint functions? Yeah, it doesn't look like it. Alright, so we'll just call it get state. Get movement state. Let's not forget our forward declaration. If state is null pointer, we're just going to return null pointer. Otherwise, we're going to see if in state lookup contains state equals false. We'll return null pointer. Otherwise, we're going to return in state lookup substate. Alright, so now we should be able to call this directly in there, grab a specific state by type, and get it. And then we can like cast it to whatever the hell we want, or set it to something, and it should be fine. Get movement state conflicts with function. Do we have a get state? Alright, it's just going to be get state then. So we're trying to finish up this system so that we can write stuff later inside of it. We're almost there. We've just been running through kind of how we're going to be using it, which is we're calling into it from the logic controller, and then how the movement controller is going to call into the states. And it looks like the movement controller can like cache the states, or just get them directly and do casts, and that'll be fine. Yeah, we could actually have the get current movement state. Yeah, we could have a lot of things on here that work with this. I'm happy with this system. Should be able to do quite a bit with it. And it won't be too incredibly difficult for me to explain it to Adam either, hopefully. Be like, well, he's in the stationary movement state, which is why he's idling there, and if you want him to change his animation, just get a callback on that event when it finishes. Alright, so inside of the Bitey movement controller, we can just call get state, and we can select a class on it, just like that. Yeah, so we can totally do that. Alright, let's just see if that all works together nicely. Stationary state with name of stationary. Excellent. Okay, so the next thing is going to be on animation events. So if we want to get called back on an animation event, like an animation is finished playing, like we kicked off an idle animation and we want to know when it's finished, how do we figure that out? I think it's on the Dashkin animation controller component. We've got the animation controller component here. The animation controller component has these multicast delegates. Animation event. So we want to grab the animation controller. Is that available? Let's go to the Dashkin movement object. I want to go to it's a public UPaper physics callback, but it's not a an object. Where is the object that we're looking for? It's the Dashkin object actor. No. It's this Dashkin entity object, which has all this stuff on it, which has the virtual controller, movement object, entity animation controller component. So what we want to do is we want to change the movement object to actually derive from the Dashkin entity object, and we want to have the fill from actor actually get called. And then we can use it inside of here properly. Alright, let's do that. So let's go to our Dashkin entity actor. Alright, we need to go to our movement object.cpp, our initialize. We need to call fill from actor. Alright, let's see what compile errors we're going to get from this, probably because of namespace conflict stuff. But our the reason I have this base entity object thing is basically inside of blueprints, if you want to access variables, it can be a real pain in the ass. So how exactly do I want to structure this? We've got this physics callback thing, which is kind of bleh. So the question is, should I use some multiple inheritance shenaniganry? Should I change the paper flipbook stuff? And they need to be U objects here because we don't want things going out of scope and screwing up our things. Looks like people have had this same problem in the past. You cannot do it. The error message is pretty explicit. You can only inherit from non-U objects of player. Blah. Yeah, so it's pretty much screwed. Let me see. So U class interface? Maybe there's something there? So maybe U interface is what we can use. I have not done this before. So instead of a U class, we make a U interface for this thing. So it's like U interface right here, and then it's public U interface, generated U interface body. So let's see if we can actually do that. Basically the problem is I want to inherit from two different things with this guy, and I don't want to make another U object or something else. I just want an interface to a thing, and I want to know if this reference counting U interfaces are not currently supported as element types. Fuck. Well, what the hell is that all about? Like, that should be simple. Alright, so if we have that, well, I guess I need to make a U-class thing here that is a callback class that calls the Dashkin movement object. I need to make a new U object that's a child to do it? God, that's such a shim. That sucks. That's not fun at all. Grr. The other thing I could do is I could just change this to a non-U object thing, and then it's basically, well, these pointers here are totally perhaps trash, and you know, make this not a U class. Just make it like so. And just be like, well, I hope you brought. I hope. Ugh. Yeah, it must be a type of U struct, U class, or U enum for it to be a U property. So basically, like, what I can do is I can remove the type checking on this thing and the reference counting stuff, and this U property can go out of scope and get garbage collected or moved around by the memory manager, and then we're just screwed. So, god damn it. There's pretty much nothing I can do with that. Alright, well, is there a better way to do it? We could just hack it in there by mimicking the same things. That's not an awful way to do it. It's not the way I want to do it. I could just have this thing not go from a U object, but it needs to be a U object to have all these properties on it. Ugh, what a wreck. I guess you'll just have to get a few things the hard way inside of that thing. Well, maybe we can just cheese the hell out of it. Why not? This class is already 2 million frickin' lines long. Why not another million? Everything in the name of usability. Alright, so fill from actor is there. Alright, so where do we call the initialize from? Let's just throw a breakpoint in there, build it and run it. If the compiler can't do it for me, then I'll do it myself. And the reason we have this Dashkin entity object, I think I explained it earlier, is if you have these variables just available in your class, you can just use them, and you don't have to like run logic through it to get it to fill out. So like with getter functions and stuff, it's just not very fun. Alright, let's compile it. Do it. Make it work. Alright, so I want to bind to an animation event inside of my movement controller. So let's see, I should be able to get animation right there. So we're going to do this inside of our initialization. Alright, so it's inside of this animation controller component. We've got this animation end delegate. So it should be like on animation end. Bind event to on animation end. Animation controller component, and then an animation ID. Right. Finished animation, and then we'll throw these 2 pins in the trash, and we'll throw this here. Alright, so when animation ends, we should be called back, and we should print it out. Finished animation. We can call twice. Do we have an error in our, let's see, animation controller component on animation end? One, two. Alright, so set playback position inside of this one. Accumulated time equals 1. Alright. So we fire it once with our set playback position. We fire it again on fire all events. Alright, let's see. Alright, so we're setting our playback position. Alright, so what are we doing? If looping, okay, so if we are looping, set our playback position, now set our playback position to 0. Timeline length. If timeline length is greater than 0, then fire all events is true. So what we're doing here is animation start. I guess we don't want to fire any events. Is this correct? If timeline length is greater than 0. Well, let's find out. Animation events are not something that PagerDuty implements. Come on, fucking Unreal. It's like you mouse over it and then it takes the focus, but because it's halted, it can't free the focus. Well, like, why do we even have fire all events here? Yeah, down here we have fire all events, it's false. So it's probably a copy-paste error that happened and I fixed it for something else. Alright. Yeah, that makes sense. You have to set playback position to 0, timeline length, blah. Yeah, alright. Why would we even call fire all events? Well, let's think about this.